All right, this is an emergency podcast for JiTT 9. I didn't realize it would cause so much trouble. So here, you're supposed to solve a cosine equation. You can follow the directions. I will be teaching that in calculus, but you can also type it into Mathematica. And then I think, let me see, I think you're able to actually tell it over some domain. So let me go back and look here, reals, integers, over the circle. Let me try this. I don't know if it'll work. Solve, and then we can put in up here. Let me see what this does. So it's telling me, okay, it wouldn't let me do that, but let's try just the x and see what happens. I'll figure this out later. Oh, I forgot to put my equal sign. Double equals 0. And then we do, let me try this again. So it won't do that. All right, so it gave me this conditional expression when I set it to 0. And what this means is it's pi over 2 plus 2 pi times an integer. Now, I want the answers that belong between 0 and 2 pi. So if I go pi over 2 plus 2 pi, that's one round, until it gives me 5 pi over 2. That's too far. And then I got minus pi over 2 plus 2 pi. That's another answer. And that's 3 pi over 2. That's definitely inside the interval. So pi over 2 is in the interval and 3 pi over 2 is in the interval. So I get these two. There must be a way to actually get that interval. I just am speed going through this, so I don't remember how to tell it to stick to this domain. But you can look it up on Google if you want, or you can interpret the solutions. So what this means is pi over 2 plus every integer multiple of 2 pi. So it's giving you all answers. So pi over 2 plus 0 is an answer, and minus pi over 2 plus 2 pi is an answer. Both of those lie in the interval 0 to 2 pi, which is the constraint that they have. See that 0 to 2 pi there? So they want that. So that's number 2. The other one that's causing people problems is this one. So let's take a look at that. You can do the same thing, and I'm going to do it kind of messy. It's again 0 to 2 pi, but I'm going to tell it to do that in general. So I'm lazy. I'm just putting everything in. And then I'm going to put double equals. And then I'm going to put 15 times cosine. And then x. And then that's solving for x. So it gave me a whole bunch of stuff. It first gave me all multiples of 2 pi, which, you know, zero's in there. 0 is a multiple of 2 pi, so 0 is one of the answers. But then when I put 1 in here, I'm out of the region of 2 pi. So this first conditional expression only gives me one answer. That's 2 pi. The second one is minus 3 pi over 3 plus 2 pi. So let's go down to here and see what I get as one possibility. And it gives me 5 pi over 3. If I do 5.0 times, I get 5 point. That's definitely smaller than 2 pi. So 5 pi over 3 is an answer. Let's go check. Look at that. They got it right. 2 pi is an answer, being at the end point, because we got that from the first one, right? If I take C1 equals 1, I get 2 pi. So 2 pi is an answer. 0 and 2 pi and 5 pi over 3. What about pi over 3? Well, that's right here. Pi over 3. So there's my 4 answers that I get for this block, for this one. And I think that should be it for difficulty. So basically you have to look at these answers If I did the Google search and found a way to constrain that domain, we can quickly check that if you're willing to sit with me. Oh, other people have done that. Ah, there it is. How do I solve a trig equation over an interval? And here it is. Oh, it says, oh, look at that. The command is reduce. Let's see what it does. Aha. So we can get the complete answer by doing that. So instead of putting solve, we type reduce, and then we put in 0 is less or equal, x is less or equal 2 times pi. Oh, isn't this fancy? There, it wouldn't do it. So let's see what this thing said. Oh, it had me do it in like this. Oh, so it gave me answers. X equals 0, x equals pi over 3, x equals 5 pi over 3, and x equals 2 pi. It gave me all the answers.